Architecture patterns are reusable solutions to recurring design problems. We have established that patterns are really important and play a crucial role in the process of software development and engineering. In this video, we will talk about patterns in depth and specifically focus on non-functional requirements. We are going to be talking about 13 non-functional requirements that either you are missing or you are not detailing in your process. Let's get started. Before we get deeper into non-functionals, let's start and understand what non-functionals really are. Non-functional requirements define the performance, scalability, reliability, and all the ET requirements of a system. These are really, quality attributes of the system. So if there's a software, how it behaves, whether it is resilient, whether it is robust, whether it is scalable, whether it is performant, whether it's fault tolerant. These are the keywords that are associated with non-functionals. Most of the times when we think about scaling a software system, we usually think that let's throw a lot of infrastructure at it and it will automatically scale. But that's poor design. We will talk about some key non-functionals that you should pay attention to, exactly 13 of them. So the first non-functional that we can talk about is performance. We all know what performance is. It's the ability of a system to be performant. It could be response time, throughput, resource utilization, anything of the above, right? The second non-functional is scalability. I don't know how I'm going to count till 13, but second non-functional is scalability. This refers to the ability of the system to increase, to handle increasing load and increasing amount of work. Now for a database, it could be increasing amount of IOPS, it could be increasing amount of data. For a web application, it could be increasing amount of users, concurrent logins, etc. The third could be reliability. These are in no particular order. This is just an order which I have established over my career and I just keep a draft of it. So the third is reliability. This refers to the ability of the system to function correctly without failure, right? Over time. Now, nobody can make a completely fault resistant system. So reliability is often a measure of fault tolerance of the system. How long was the system performing without having a fault? A fault could be anything. It could be crashing under load. It could be a code breaking up. It could be infrastructure. The reasons could be many. Fourth, security, right? This refers to the system's ability to protect itself against, let's say, intruders, unauthorized access, data theft, security threats, vulnerabilities, etc., etc. These could be, the way to solve about security could be authentication, access control, encryption, compliance with different standards like ISO, etc. Number 5, usability. This is very much ignored and largely covered in the functional requirements, but usability refers to the ability of the system as to how well it has met the user needs. It's a very abstract idea. How do you measure it? You can measure it maybe by responsiveness. Responsiveness could be a good response time, and responsiveness are two very different things. UX design is is an area which probably encapsulates a lot of usability. Maintainability. How well the software is maintainable. Is it rightly modular? Is it well documented? Are the interfaces defined rightly? Is there enough code quality matrix around it? So the maintainability is a very important matrix once a product or a software has moved from development to production lifecycle. Number 7, interoperability. This refers to the ability of the system to interact with other systems. So data exchange formats, properties, files, integration with third-party methods to support like RESTful, file transfers, etc. Compatibility. This refers to the system ability to work with different kind of hardware, software, probably also network environments. So you could design a system which will run in a very certain kind of an environment, like Windows will require a certain software specification, and the other could be, you could have something like a Docker which will be multi-cloud and run multiple places. Compatibility is a very important factor from a large perspective specifically when you're starting a project. It's not so much important when you continue and move forward. For example, in Android app development, compatibility with previous versions is a very important factor. You have to always maintain certain number of backward compatibility with app developments. Availability. This is basically the system's ability to be accessible all the time, or again during the time window which has been agreed upon. It could be 365 days, it could be 99.5%. This is basically the system's ability to be up for its user. I think it also covers the recovery time objectives. For example, during the period it is down, how much time it takes to be up, right? So measures like MBTR, like mean point between failures and things like that, operational metrics, they are usually covered under availability. Capacity this refers to the system's ability to handle a certain kind of a volume or a traffic or number of transactions. Compliance, this refers to the system's ability to meet legal, statutory, regulatory requirements. For example, you have to comply with GDPR when you build software for Europe. Your data has to be stored physically within certain boundaries, certain geographical boundaries, to respect the compliance needs. So this is a compliance requirement. A lot of times this is part of functional requirement too. Performance efficiency, right? This is basically how performant the system is, and it could be a lot about whether the resource utilization is optimal or not. A lot of times I have seen people overuse infrastructure, and while the utilization is often measured. So if you have a server, you should try to be up to 60-70% utilization and not 20%, because you're wasting a lot. I think 60% is a good rule to be around as an average. 80% sometimes people get jittery when you have a system which is always running at 80%, because then it implies to them that it cannot handle load or something like that. So 60 to 65% is a good number. Below 50, you're not optimizing your servers well. Number 12 or number 13, testability. This is how well the system should be tested, right? Whether have you tested around data management, have you tested about traceability of tests? So this is overall ecosystem of testing. You can have more non-functional requirements. I've talked about 13, but we can also talk of disaster recovery. We can talk of deeper compliances. We can talk of external vendor driven matrix in non-functional. So non-functionals are a very, very large area. So it's important to learn to prioritize them. How do you prioritize NFRs? Well, there's lots of techniques out there. One of the most simplest techniques is MOSCO, which stands for 4 categories: must have, should have, could have, and won't have. So you can build a 13x4 and say which is important to you and which is not, and basis that matrix you can decide that I want to keep these non-functional as a part of my first iteration, as a part of my subsequent iterations, and so on and so forth. So yeah, that's Akash Verma signing off on non-functionals. In the next video we'll talk more in depth about architecture patterns. We'll take a deeper dive into technology stacks and the different stacks that we have in today's world. Stay tuned to Cafe.io. Bye bye.